So this is your problem. So the two signals x1, x2, you have to find whether it is power or energy signal. So first you write the signal. So this is the formula for your energy signal in the discrete domain. Okay. So energy signal in the discrete domain. So now we have to apply the signal. Okay. You are applying the signal. So 1 by 3 the whole power n into u of n. So what do you mean by u of n? So u of n represents what? What type of signal? You can just put it in the chat. U of n represents what? This u of n. What signal it is? Type in the chat box. What is u of n? So first class itself I have said. So u of n is nothing but your unit step signal. Okay, unit step function. Okay, it is u of n is unit step function. So don't forget it. So it is clear that nobody is following the class, and it will be difficult for you if you are not following the class. Okay, day to day, the problems what I am giving, try to finish it. Okay, so now it is unit function means we'll be putting the value n equal to 1. Okay, minus infinity to infinity summation 1 by. So u of n becomes 1. So 1 by 3 the whole power n the whole square. So your u of n is 1. So 1 you no need to write. Okay. So next what happens? So here the square. So the square I can bring it inside. So n equal to minus infinity to infinity. So you can, if you are bringing inside means 1 by 3 square the whole power n modulus of square. Okay. Modulus of square. Okay. So now what happens is, so this square you can take it out. Okay, so this square you are bringing inside. So the square has been bringing inside. So 3 square value is will be getting us 9. 1 by 9 the whole power n. Okay. So what happens is, here for your u of n will be equal to 1 for positive values, for n greater than equal to 0. Okay. At the same time, for the negative values, your u of n will be equal to 0. So this we have already dealt in the first class. Okay. So now what you have to do? So this is the thing over here. So for this you can, there is mathematical empirical formula for solving this. So the formula is 1 plus a square plus a cube up to infinity. You'll be getting 1 by 1 minus a. So here what is the thing is, you have to convert this into 0 to infinity. Okay. So as you know, the u of n is a periodic function, right? So u of n is a periodic function. So here you can convert this into 0. So this becomes 0 to infinity. This becomes 0 to infinity. Okay. So this becomes 0 to infinity. So from 0 to infinity, okay, from 0 to infinity, we will be getting the value. Okay, we'll be applying this. Then you don't need to apply for each and everything. Okay, the formula is there. So you can directly apply the value. If this is a value means, so you will be getting as e equal to 1 by 1 minus a, which is nothing but 1 by 9. So we will be getting 1 by 9 minus 1 by 9. We will be getting the answer as 9 by 8. So E has some definite value. Okay, so E is having some definite value as 9 by 8. Okay, Now we'll be moving with the power. So the power P formula is P equal to limit capital N tends to infinity 1 by 2n plus 1 summation n equal to 0 to capital N 1 by 9 the whole power n. Okay. So now what you have to put? You have to again go with the formula. Okay. So if I again going with the formula means in here, so you'll be getting P equal to limit n tends to infinity 1 by 2 n plus 1 into 1 minus 1 by 9. So for this is the sub formula is there. Over here there's a formula is there. Okay. 1 by 9 the whole power. Okay. That is this part you are applying. So this n normally changes to capital N. So it will become n plus 1 divided by 1 minus 1 by 9. Okay. So over here, what happens is, if you are applying this infinity results, infinity to n, that is 1 by infinity. Okay. So for the capital N, you are applying, that is your n tends to infinity means you are putting your n value to the here. So 1 by infinity is nothing but 0. Okay. So we'll be getting as p equal to 0. P value, again I'll be writing that. Okay. Limit n tends to infinity 1 by 2n plus 1 into 1 minus 1 by 9 the whole power n plus 1. You can even solve this bracket, but again you'll be getting the value of 0. Why in the sense means here it is infinity. So 1 by infinity you'll be getting 0. So as per condition, the energy is finite. Okay, energy is finite. Okay, and power is 0, so it belongs to a energy signal. So it is a energy signal. Okay. So the second thing is, second signal x2 of n equal to e power 2n into u of n. Okay. So for this, we are going to find the energy and power. So E equal to summation n equal to minus infinity to infinity. The same formula x of n the whole square. Okay. So here, how we can find this is periodic in the sense means again here there's a unit function. Okay. So if there's a unit function means to be from a periodic. So you just apply the substitute the values over here. So we'll be getting e power 2n. Okay, e power 2n u of n the whole square. So now you have applied it. So now you have to make this as a periodic. So this becomes summation n equal to 0 to infinity. Okay. So u of n will be 1. Okay, u of 1 will be 1. So e power 2n. Okay, e power 2n the whole square. So 2 you bring it inside, so it will become summation n equal to 0 to infinity. It will be e power 4n. Okay, e power 4n. Okay. So now what happens is you have to apply this formula. So you have to expand this. You have to expand this. Okay, expanding means you'll be getting. Expanding means we'll be getting just you put 1 plus e power 4 plus That is n equal to 0 means you'll be getting 1. N equal to 1 means you'll be e power 4. Then again means e power 8. Okay, e power 8. Okay. Similarly, it goes up to infinity. So here it is clear. Here what is clear? This takes the value of infinity. Okay. So your value becomes infinite. So your E is infinite. Okay. So in the previous case, the energy took the definite value, but in this case, it is infinity. Okay. So next we'll be going with the power. So as per power, P equal to limit n tends to infinity 1 by 2n plus 1 summation n equal to minus n to n whole square. So now what you have to do, you have to apply substitute the x of n. So it will be limit n tends to infinity 1 by 2n plus 1 summation n equal to, you can take it as periodic, so you can take n equal to 0 to n, so it will be e power 2n, so again it will become 2, so 2 will be coming inside, so we will be getting 4n. Okay. E power 4n. Yes. Now we have to put the formula limit n tends to infinity 1 by 2n plus 1. So now if you are putting the formula means e power 4 n plus 1, that is here it becomes e power 4. Okay. Here we will test if whether the value will be greater than 1. Okay. If it is greater than 1 means you have to go with this formula. If it is less than 1 means you have to go with the previous formula. So here it takes the greater than 1 only. Okay. So you have to put this minus of 1 by e power 4 minus 1. Okay. This formula you might have gone through in your mathematics. So again here it is infinity is there. Okay. So if I substituting here, it becomes yeah. So here what happens is the e power n tends to infinity, it becomes infinity. Okay. So why in the sense means here this e power 4n will be in this. It gets subtracted from this one. Okay. So you'll be getting this infinite. So here the power is also infinite, energy is also infinite. So in general, you'll be getting both the power and energy are infinite. So hence your signal is neither power nor energy. Okay. So this is what with respect to your problem. We just go through for 5 minutes and then we'll be moving to the next problem. So okay, now we'll be going to the next problem. So the previous problem was example 23. So this becomes your example 24. Okay, example 24. So you just yeah, so you just have this. So I'll be putting the question. Okay. So you just take down the question. What is the input signal take down the question. What is the input signal x of n that will generate the output sequence y of n. Okay, y of n okay. So what is the input signal x of n that will generate the output sequence? So the sequence is y of n equal to 1 comma 5 you just take the question 1 comma 5 comma 10 comma 11 okay, comma 8 comma 4 comma 1. Okay, so this is what you have to see. So this is your y of n. This is your y of n. So for a system with impulse response h of n equal to 1 comma 2 comma 1. Okay. So what they are asking, what is the input signal x of n, okay, that will generate the output sequence y of n. They are asking the input signal by giving the output signal. Okay, with your impulse response, the response is impulse. Just again, I have shown you about the impulse function in the previous lectures. You can just refer with that. So h of n equal to 1 comma 2 comma 1. Okay, yeah. So first you write the given. They are asking the input signal by giving the output and your response. Okay, so given, so your output y of n is equal to 1 comma 5 comma 10 comma 11 comma 8 comma 4 comma 1. So here how many samples are there? 1 2 3 4 5 6 and 7. So here there are 7 samples are there. Okay, so here there are 7 samples are there. So next your h of n, your response, which is 1 comma 2 comma 1. Okay. So what is the input signal they have to find? So to find input signal, okay, they asked to find the input signal. So solution. So first what you have to see is you have to get to the number of samples. Okay. So the number of samples in output. How much samples are there? There are 7 samples. Okay, there are 7 samples in output. In your response, there are 3 samples. So for this, there's a formula already there. So here, with that, you can take can see how many samples are there in your input. Okay. So first, what you have to know is the samples in the output, the samples in the response. Okay. With these two things, you can get the number of samples in your input signal x of n. Okay. So here the formula is n1 plus n2 minus 1 is equal to 7. Okay. The simple thing here is, so this, with this you can get the n1. Okay. So n1 is nothing but the number of samples in your input. Okay. Number of samples in your input. So number of samples in your impulse responses n2 equal to 3. Okay. Now substitute this value over here. So we'll be getting n1 plus 3 minus 1 equal to 7. So n1 plus 2. Okay, here it is 2. So n1 equal to 7 minus 2, which is equal to 5. So your x of n has 5 samples. X of n has 5 samples. So next thing is you have to find the elements in your x of n or the samples in the x of n. For that there's a formula. So take it down. X of n equal to y of n minus summation k equal to 0 to n minus 1. Okay. X of k into h n minus k. Okay, h n minus k, the whole divided by h of 0. Okay, in this formula you have to substitute each and every value and you have to find the value of x of 5, that is x of n, that is the samples of x of n you have to find. Okay, so now take it down. First you have to put the 5 samples, so it will be moving from 0, 0, 1, 2, 3, 4. Okay, so like that will be going. So put n equal to 0. So your x of 0 will be equal to y of 0. Okay. So here the catchy thing is, so you'll be putting n equal to 0. So 0 goes out. So minus 1. So this thing, okay. So if it is 0 means will be, this value will be minus 1. Okay. Can you understand, right? That is minus of summation k equal to 0. So 0 minus 1. So for minus 1, what happens? For minus 1, there's no value in your h. So here in general, they will be giving an arrow. Okay. Here, they will be giving one arrow over here and here. So now this becomes your zeroth value. This becomes your zeroth value and this becomes your zeroth value. So if they're giving apart from this means it becomes your -1 value. So in both the conditions, that is in your input and in your response, there is no -1 values. So what you can do is this entire part you can make it as 0. Okay. This entire part you can make it as 0. So it becomes y of 0 minus 0 by h of 0. So y of 0 means y of 0 refers to your first value. Y of 0 means first value. Y of 1 means this value. Y of 2 means this value 10. Y of 3 means 11. Y of 4 means 8. Y of 5 means 4 and 6 means it will be 1. Okay, here similarly 0 means this one and 1 means this 2 and 3 what you can say 2 means this one. Okay, so now we have to substitute the 0 values. So in both the output and your response, your 0 value is 1. So you'll be putting 1 by 1, you'll be getting the value 1. Okay, next for, so this is first value. So this is the first value in your x of n. Now for n equal to 1, so x of 1 will be equal to y of 1 minus so k equal to 0 and this value becomes 1 minus 1. Okay, x of k h of n minus k. So it is 1 minus 1 means in value will be 0. So you will be putting k equal to 0 by h of 0. If you are substituting means y of 1 minus x of 0. So this n value also becomes 0. So this minus k will be putting 0. So it will be 0 by h of 0. So y of 1 value is this 5. Okay, y of 1 value is this 5. You have to substitute in that. You have to substitute in this 5 minus. So x of 0 is this previous value. This previous value is your x of 0. Okay. So this x of 0 is 1. Okay. 1 into h of 0. So h of 0 is already we know it is 1. Okay. By h of 0, 1. So it is 5 minus 1, which is nothing but, sorry, h of 1 it will be coming. Wait a minute. So here I made a mistake. Okay. So that is, I have put on 0. Here it is not 0, right? So it is n equal to 1. So it will be 1. So 1 minus 0. So here h of 1 we will be putting. So h of 1 is value is 2. Okay. So 1 minus 2 will be getting the value as 3. So here you have to be careful. Okay. You have to be careful. Okay. So just take it out. Then we'll be going for n equal to 2. Removing for n equal to 2. For n equal to 2, you have to put x of 2 equal to y of 2 minus, okay, you have to just substitute it and see. We'll be getting like this: x naught into h of 2 minus x of 1 into h of 4, okay, divided by h naught. So h naught is 1. Substitute the values from the given. So we'll be getting 10 minus 1 into 1 minus 3 into 2 by 1. So we'll be getting 10 minus 1 minus 6. So it will be 3. Yeah, this for n equal to 2. Then for n equal to 3, x of 3 equal to y of 3 minus x of 0 h of 3 minus x of 1 h of 2 minus x of 2 h of 1. So one value gets keep on increasing and another value gets keep on decreasing by h naught. We getting 11 minus 1 into 0 minus 3 into 1 minus 3 into 2 by 1. So we getting 11 minus 0 minus 3 minus 6 and we getting 2. Now for the final for n equal to 4, x of 4 equal to y of 4 minus x naught x of 0 h of 4 minus x of 4 h of 3 minus x of 2 h of 2 minus x of 3 h of 4. The entire divided by h of 0. Yeah. Now we have to substitute from the given values. So x of 4 would be equal to 8 minus 1 into 0 minus 3 into 0 minus 3 into 4, sorry, 1, 3 into 1 minus 2 into 2 by 1. Okay, it will be 8 minus 1 into 0, 0 minus 0 minus 3 minus 4. So it will be getting the value 1. Okay, so now we have got the 5 samples. So the signal is x of n equal to 1, 3, 3, 2, 1. Okay, so that's how the problem ends. Okay, let's go through the problem. We will move to the next problem. So it will be example 25. Example 20.
Sir. Sir.
Chula Adishankar.
Sir.
Adishankar, wait a
minute.
Wait.
இல்ல சார், தப்பா எழுதிருக்கீங்க.
Example?
இல்லை சார் n = 4ன்னு சொல்லி ஒரு ஸ்டெப் கடைசி ஸ்டெப் போட்டிங்களா அந்த ஃபார்முலாவில் தப்பு
ஆமா.
இருக்கு. இந்த ஸ்க்ரீனுக்கு அப்படியே முந்தின ஸ்க்ரீன் சார்.
ஜஸ்ட் இந்த இல்லையா?
அந்த இடத்துல x(4)ன்னு போட்டிருக்கீங்க பாருங்க, x(1)ன்னு வரும்.
x(1) இங்கே தானே?
அங்கதான்.
ரைட். x(1) அதான் a particular will be getting increasing and another particular will be getting decreasing. So x வந்து பாத்தீங்கன்னா it will be increasing. அதே இது உங்களோட ரெஸ்பான்ஸ் h வந்து பாத்தீங்கன்னா அது it will be decreasing. ஓகே, பட் ஆனா அந்த வேல்யூ வந்து கரெக்டாக தான் போட்டிருப்பேன். ஓகே, ஸோ இங்க எழுதும் போது தான் தப்பா போட்டிருப்பேன். ஸோ பை when I am working out I have okay. So now we'll be going for example 25. So from this example 25 you can expect for gate questions. Okay, so gate questions வந்து நீங்க வந்து எக்ஸ்பெக்ட் பண்ணலாம். சின்ன ப்ராப்ளம் தான். So the problem is determine whether the following signals are periodic or not if they are periodic specify its fundamental period. Okay, they are going to ask, they are asking to find whether the signals are periodic or not. If it is periodic means they are asking you to find the time, the fundamental period. How the time period, that is the fundamental period for the which amount of time period the signal gets keep on repeating, they are asking to find. Okay, so first one is x of n equal to e power j 6 pi n. Okay, this is the first one. The second one is x of n equal to cos pi by 3 n plus cos 3 pi by 4 into n. Okay. So we can go with the given. So given you will write these signals. Okay, so to find you will write, so you can directly jump onto the solution. So solution is first one, x of n equal to e power j into 6 pi n. Okay, so for this x of n equal to e power j 6 pi to n. So here you have to take the time period this value. Okay, so if this is the time period means that is your omega naught will be equal to, so here you won't be going for t. Okay, here you will be in discrete, you will be representing with respect to the radian per second, which is your omega naught. Okay, omega naught equal to this value, which is 6 pi. Okay, so here this is your fundamental frequency. So this you can write the fundamental frequency is a multiple of pi. Hence, signal is periodic. Okay. So now the second thing is x of n equal to cos pi by 3 n plus cos 3 pi by 4 into n. So this is a very similar problem. Okay, we have already seen in finding the periodicity. Okay, so you can just refer with that. Okay. So here the thing is, for the fundamental period, for cos pi by 3 to n, okay, is n1 equal to 2 pi into m divided by this value. So it will be getting pi by 3. Okay, so this m will be equal to 1. Take m, for m equal to 1, your n1 will be 2 pi divided by pi by 3. So pi by pi cancel. So 2 into 3 will be getting 6. Okay, so this signal is also nearly all the cos signal, whatever the cos signal is coming, will be periodic. So it is a periodic function. Okay, it is periodic. So next, for this one, the fundamental period for cos 3 pi by 4. Okay, for cos 3 by 4 is n2 equal to 2 pi, okay, m by 3 pi by 4, the frequency. Okay, so for m equal to 1, so wait, we'll see this previous steps. Okay, okay, listen here. So here the thing is, this m value I have been saying, right? So the m value is nothing but the value in the numerator. Okay, the value in the numerator in this period. Okay, so for example, we just take this. So for cos pi by 3, n. Okay, so here omega equal to pi by 3. Okay, so in general your omega will be equal to this numerator, for what you can say, m into pi by 3. Okay, so here m value will be equal to 1. Okay, similar to that for cos, what you can say, 3 pi by 4 into n. Okay, your omega equal to 3 pi by 4. Okay, but here your m value is 3. So now what you have to do is, here you should not put m value 1, you have to substitute the m value with 3. Okay, so for m equal to 3, you'll be putting n2 equal to 2 pi 3 by 3 pi by 4. Okay, so now what happens, 3 gets cancelled, pi gets cancelled. Now you'll be getting 2 into 4, this is equal to 8. So n2 is 8. So now we have found out the fundamental period for this one, this function and this function as a separate one. Okay, now we have to find for x of n. If you want to find for x of n means, what you have to do, your n1 by n2 first you have to find. n1 by n2 is 6 by 8, which is equal to 3 by 4. Okay, so now what you can say is, your n value will be equal to 4 times of n1. At the same time, it will be equal to 3 times of n2. So now you have to put 4 into n1. What is n1? It is 6. It will be the same as 3 into n2. What is n2? 8. So it will be the same. So it will be 24. Okay, so like this you have to find. Okay. So this is how you have to find your fundamental period. Okay. So you have to be clear about this m value. So this m value plays a major factor. Okay. So okay, this lecture gets concluded. Okay. So